Hello and welcome to Learning Math in Simple English with Sergeant Hiromatsu. Today's topic is exponential functions and their graphs. Exponential functions are really interesting and they're very useful, and you can find them in biology and chemistry, physics, almost anywhere. So today's goals first is to understand some of the basic properties of exponential functions. Also, we want to draw graphs of exponential functions. And we also want to compare exponential functions, how they get bigger, how they get smaller, etc. So, what is an exponential function? An exponential function is a function of the form y equals a to the x, and a is greater than 0, but not 1. Here a is called the base, and x is called the exponent.
Okay, let's take a look at an example. Y equals 2 to the x. So for example, if x equals 1, this is 2 to the 1. Or, as you know, that's just 2. If x is 2, this is 2 squared. X is 2. And that's just 4. And if x is 3, you get 2 to the third power, which is just 8. And you can see this gets big very quickly. 2, 4, 8, 16, 32, 64. Very quickly, this gets really big. Okay, so how about if x is 0? If x is 0, we have 2 to the 0th power. And you know that's just 1. If x equals negative 1, we have 2 to the negative 1. Well, that's just 1/2. Remember, you want to take the reciprocal of 2, the inverse. Okay? And if x is negative 2, we get y equals 2 to the negative 2, which is just 1/4. And you can see that this gets smaller and smaller. It gets closer to 0. So 1/2, 1/4. Next would be 1/8, 1/16, 1/32. It gets small very quickly. Okay, so let's have a look at some graphs of exponential functions.
So if x equals 1, then y equals 2 to the first power, 2 right here. Okay, so I'll draw a dot here. X is 1, y is 2. If x is 2, then y is 4. If x is 3, then y is 8. Okay, so you can see it's getting larger and larger. And the next would be 16. Okay, so if x is 0, then what is y? Y equals 2 to the 0, that's y equals 1 right here. Okay, so I'll draw a dot here. And then if x is negative 1, then y is 1/2, getting very small here. And if y is negative 2, if x is negative 2, then y is 1/4. Okay, so this becomes a graph like, let me try that again. Comes like this. It slowly gets bigger, slowly. And then all of a sudden, very quickly. So this is a graph of y equals 2 to the x. And if you'll notice here, we have an asymptote. Okay? So you see here, it gets closer to the x-axis as x gets smaller. It's very close to the x-axis, and that's an asymptote. Okay? So the x-axis is an asymptote. X-axis is an asymptote. 全近線, right? Okay, so this is, so in general, you can see here, if a is greater than 1, then y equals a to the x, this graph, well, it's increasing, so it goes up, and it goes up very quickly. And if x is 0, then it's always 1, no matter what a is, this is always 1. And then if x is 1, then it's a to the first power. So x is 1, y is a. Okay, so this, no matter what, the a. All right, now if a is between 0 and 1, like for example, if a is 1/2, or if a is 3/4, then it'll become this kind of graph, a decreasing graph. And that's because this gets smaller and smaller. So if a is 1/2, then this is 1/2, and next x is 2, a is 1/4, x is 3, and y is 1/8, etc. So if a is in between 0 and 1, this is a decreasing graph. But if x is 0, then y is still 1. Okay? And if x is 1, then y is still a. This is the same as before.
Okay, so let's check some of the properties of exponential functions, like y equals a to the x. So first of all, the domain is the reals. This just means, in Japanese, 定義域が実数全体. And the range, 地域, is positive reals, 正の実数. Okay, so first of all, if a is greater than 1, then what does the graph look like? What does this graph look like? I'll draw it really quick. It's going up, right? It's increasing. So if x gets bigger, if the exponent, right? If the exponent gets bigger, then the y value also gets bigger. So if x gets bigger, y gets bigger. If q is bigger than p, then a to the q is bigger than a to the p. That's fine. And the other way around, if a is between 0 and 1, then the graph looks like this. It's decreasing. And you can see if x gets bigger, then y gets smaller, right? So if q is bigger than p, then a to the q is smaller than a to the p, right? Because as I go to the right, the graph gets smaller and smaller. Y gets smaller and smaller. Okay, so that's pretty easy to understand, but just remember, it switches. If a is greater than 1, then x and y do the same thing. X gets bigger, y gets bigger. If a is between 0 and 1, if x gets bigger, y gets smaller. Okay, so how can we use this? For example, which is larger, the 5th root of 6th or the 7th root of 64? Now, first of all, we need to get a common base. We can see both 16 and 64 are powers of 2. So I'll write like this. The 5th root of 16 is the 5th root of 2 to the, this is 2 to the 4th. And this is just 2 to the 4/5. And what about the 7th root of 64? Well, 64 is 2 to the 6th, right? And that's just 2 to the 6/7. So here, which is bigger, 4/5 or 6/7? 6/7 is bigger. So now remember, 2 is greater than 1. So if the exponent is bigger, then the value is bigger. So the answer is 2 to the 4/5 is smaller than 2 to the 6/7. Therefore, the 5th root of 16 is less than the 7th root of 64. Okay, so these are some basic properties and important properties of exponential functions. And so today's lesson, we learned what an exponential function is, how to graph it, and some important properties of the functions. Okay, thank you for listening.